In a right triangle, one angle measures x degrees, where sine x degrees is 4/5. What is cos 90 degrees minus x? All right. If you have this fact memorized, you're done, and it takes you 5 seconds. There's a trig identity that says sine x is the same as cos 90 degrees minus x. And if that's the case, if you have that memorized, you're done. If sine x is 4/5, then cos 90 minus x is 4/5. The answer is 4/5. Circle it, call it a day. Now, let's pretend we didn't know that, because not everybody has all the trig identities memorized, and no one expects everybody to have all of those memorized. It's just one of those things where if you have it memorized, you're in luck. I want to understand from the graphical point of view. All right, so I'm going to draw what sine and cosine look like and compare them to each other. All right, so magic happens at 90 degrees, at 180 degrees, at 270 degrees, and then it repeats itself at 360 degrees. I'm going to graph sine in red here. Okay, and this is what sine looks like. Sine starts at 0, 0. It peaks out at 90 degrees, goes back to the x-axis at 180, goes down and restarts at 360. This is sine. Cosine starts out at the very peak here, crosses the x-axis at 90, okay, hits a hill there, and then starts back over at 360. So what it looks like is if I were to take sine, right, and shift it over, move it left 90 degrees, I would get cosine. Okay, so cosine seems to be 90 degrees more. So sine is going to be cos 90 minus whatever it is. So that's where this comes from. So you still get 4/5 because there's a horizontal shift, where if I take 90 degrees, scooch it over, I end up with the same exact thing. So that's how sine and cosine work out from a graphical point of view. That's how they're related. This is just a fun trig identity. I had so much fun doing it. I hope you did too. The end.